So, problem number 11, it says, hey, I've got the area under the curve of f of x from here to here, and that equals 5. Whoops. Dx. Then I have the area under the curve from 4 to 4 and 4 to 6. Well, just think of this, okay? So I've got a graph. Who knows what it looks like? Something like that. And so from 4 to 6, we do the math. This right here, the area under the curve is 5. All right, now let's evaluate the area under the curve from 4 to 4 of f of x dx.
0.
If I go from 4 to 4, I'm just going to do from 4 to 4. What is that?
0.
0, because there is no width.
Yeah,
There's no width to calculate the area under the curve, so that's 0. Now, the next one, this one here, is a property. If I say the area from 6 to 4, this is just one of the properties of integrals.
It's negative 4 to 6.
Whenever we flip the upper and lower boundary, the area under the curve is the same, but instead of measuring it from here to here, we measure it from here to here, so it becomes a negative 5. Now the reason for that is that, remember, we're going to take your antiderivative of f of x, and whatever that antiderivative is, we're going to evaluate it from a to b, where we say capital B minus capital A. But when we flip that around, then we would say capital A minus capital, or not capital B, big F B subtracted from A. And so the value, the numerical value will be the same, but because we're flip-flop the order, we'll end up with a negative sign instead, or the opposite, or the negation of it. Does that make sense?
So they give you any answer, they give you one. In the question, they give you one answer.
Well, they're just properties. Let me explain this to you, okay? Let me list the properties so that you know what they are. They're in your notebooks, they're in the calculus flashcards and all that stuff. But basically, if I say a to b of f of x dx, right? And that equals something. Let's just give it a value. Equals some constant c. It doesn't have to be a constant. It could be anything. So let's do f prime. Well, that would be some function of x. Evaluated from b to a. That looks like this. F of b minus f of a. Now, if I flip-flop that and I evaluate f prime dx, then it's going to be f of x evaluated, but now you flip-flop it and you go from b to a, and so then that gets evaluated f of a minus f of b.
I think I was just confused on why they gave us the first part of the problem. Like,
Well, this will always be, if I say f prime of x and they're the same value, then that's going to be f of x evaluated from a to a, which is really f of a minus f of a, which is 0. So whenever your upper and lower boundary is the same, that will always equal 0. If this equals 5 and you flip-flop the boundaries, then it would just be the opposite. If this would have been negative 5, then this would be plus 5. So these are just properties. I mean, you can crank through the math like Mr. Adams did, but that's why they didn't give you a function, and so it doesn't allow you to have an antiderivative, so it doesn't allow you to... this is just a property that you can memorize. It should have been on the flashcards, but...
So if I said,
Alright, that's easy.
if I just did like the normal way, like if I graphed it and then found the integral, it would still get negative 5.
Try it sometimes. Graph a function. Let's try it real quick so you guys can see. So if I go the question that I was asked was, Mr. Adams, if we graph something and we evaluate it under the curve, let's do that. So we're going to graph just your basic. Let me turn some things off here. Plots off 4. Enter and then zoom standard 6. All right, there we go. Boom. Basic parabola x squared. Right. So now if I want to calculate the area under the curve, and I go, let's do 2. No, wrong one. I want to do area under the curve. So I got to go second trace. I did the derivative. So if I go my lower limit, let's do 1. And then we'll do 2. And I don't know if you guys could see that, but it's like 0.17. It's a very small amount. But now I'm going to do it backwards. So I'm going to hit second trace, and I'm going to evaluate the area under the curve. But now for my lower limit, I'm going to go 2. And then my upper limit, I'm going to do 1. And now you see that we have a flip-flop. See how that changed? It should have been the same numerical value, 2 to 1. Let me try that again. Maybe I didn't hit it right.
Okay.
So if I do the lower limit of 1, yeah. So I didn't hit it right the last time or something. Yeah, so now it's positive 2, 3. So depending on how I calculate it, what you're doing is you're choosing to do it this way, or you're choosing to do it this way. So you can think of it, it's like 3 minus 2 or 2 minus 3. Both of them, the answer is 1, but one is negative 1, the other is positive 1.
Gotcha.
Okay, and that's just part of the algorithm.
It's just a property.
Yeah, and it's just property. You can just memorize property.
Yeah.
Okay, any other questions on this?